Hello, our beloved students of the 6th grade in the distinguished schools. This is Dr. Hamza Al-Janabi, and I'm going to be teaching you physics for the rest of the year. In the first chapter, we talk about capacitors. And the first thing coming to your mind is, what is the capacitor and what is the capacitance itself? So if we want to describe or define the capacitor itself, we can define it in that way. So we can say easily that the capacitor consists of two identical, isolated, and parallel conductive plates. The area of each of them is A, which is equal. They are separated from each other by a distance called D, and charged within two charges of the same size and different types. What does that mean? That means that we have two plates. Both of them are of the same area. So both of them have the same area. And we represent area with the letter A, capital A. So if this A equal 10 centimeters, this A should be also 10 centimeters. And they both identical with the same area. And then we have to mention that they are conductive. The plates are conductive, should be conductive plates. And then we should mention that these two parallel plates are separated by a distance called D. So this is the distance between them, which we call D, which is distance. Okay. This is the general definition of the capacitor. Two parallel plates of the same area and then separated by the distance D, and both of them contain charges, okay? Let's assume here that we have a power supply here, which is, let's assume it as a battery here. And then this could be charged with positive charges, and that side will be charged with the negative charges. So the number of charges are equal on both of them, but the type of them are different. So if I want to summarize the definition of the capacitor, we can say that it consists of two identical, isolated, and parallel conductive plates. The area of each of them is A, and separated from each other by a distance D, and charged with two charges, okay? And they are equal to the size, but different in types. And let's imagine, in reality, what is the capacitor? And what is the main benefit of the capacitor? So in the capacitors, we say is that the main purpose of the capacitor is to store, first, charges, and second, energy. This is the main purpose of the capacitors. Store charges, as we see here when we provide it with a power supply, for instance, a battery, and then it was stored with the charges. And let's see how that's really happen in the reality. Let's see this example. So for here, my beloved students, we can see that this is the two parallel, isolated, but conductive plates here. And then we connect them with a power supply. In our case, it's a battery. Let's support it with the voltage. Let's say, for instance, or for example, that we have provided with 1.5 volt. And then we can see that the first type, which is connected to the positive side of the battery, is fully off charge with the positive. And the negative sides of the battery provided the negative charges to the other plate. And here we can say that there is a distance between them, it's called D, and each one of them have an area, represent them, and they are equal and identical. Okay, so let's remember together. We said that the capacitor main purpose is to store energy and also to store charges. And then we saw here that it's already connected and it's storing the charges. But what is the idea here? Let us disconnect it from the power source. And then we see that even when it is disconnected from the power source, it still contains the same charges. And this is a good idea that prove that one of the purposes of the capacitor is to store the charges. And by default, when it stores the charges, we know that there's an electric field between the positive and the negative charges, which means that it stores the energy as well. This is very and well noted. Then now, let's see if we connect it to a light, for instance, and it's not anymore connected to the power source. It's only connected to the, it's not connected to anything, but we're going to connect it to the light. Let's see what's happened. Let's connect it to the light. Then we see that the light it's working. It starts to shining until all the charges are going into it and change into another way of energy. Let's repeat it again. So we will charge it. It's full of charge. Then we disconnect it. Then we connect it to the light. And we see the light is work until all these charges are vanished. This is a good idea. So right now, we know what is the capacitor. We said that it's two parallel isolated conductive plates, and both of them are equal in the area and separated by a distance d. And also, it's contain the charges that we talk about. Both charges are same in quantity but different in their types. Now, let's assume that we have a manufacturer and we are producing capacitors. And I have a manufacturer and we produced two capacitors, one of them of 10 microfarad and the other one of 5 microfarad. How does that happen? Let's imagine how the capacitance of the capacitor itself is defined or identified. So it's depend on three main elements. One of them is the area of the plates. Once this plate, the area of the plates, became larger, that means we store more capacitance and we store more charges, and then the capacitance itself will be increased. And then if we reduce the area, that means the number of charges is less, and then the capacitance itself of the capacitor will become less and less. So why this capacitor was 10 and why this was 5? One of the reasons could be the area of the plates. So the area of the plates at the 10 microfarad, it was like this. And then I produced another one with less area of the parallel plates, and it then became a 5 microfarad. This is one of the reasons. And the other reason is what? The second element that affects the capacitance of the capacitor is the distance between them. So let's assume we have this capacitor as a reference, okay? And then we reduce the distance between the plates of the capacitor. So when we reduce the distance, that means we will have more capacitance in the capacitor. And if we increase the distance, we will have less capacitance in the capacitor. And later on the other lectures, we will prove that in mathematics. Why does these things happen? But keep it in mind, this is two elements. There is a third element. The third element is what is behind or between these two parallel plates. Is it the air itself? If it was only the air between those two parallel plates, it means something. And if it was something else, like a dielectric, we put a dielectric here, also this will affect the capacitance of the capacitor. So if we ask ourselves why we have a capacitor of 10 microfarad and why the other is 5 microfarad, the reason that maybe could be the area, could affect the capacitance of the capacitor, maybe could be the distance between the two plates, and the third reason is what is between them? What is between the separating the two parallel plates? Is it the air only, or there's a dielectric between them? These three things could affect. And then we will talk about what types of dielectric we could put between these two parallel plates to separate them. Let's see in the example. We came through that there are three elements, and one of them is the dielectric. And the dielectric we have in our curriculum two types of dielectrics used in the capacitors. And let's say it here and for all, that when is a dielectric inside a capacitor, it will directly increase the capacity of the capacitor. How? Let's say that when there is a dielectric in the capacitor, that means CK equal K multiplied by C. That means the capacity of the capacitor will be increased no matter how, or the type of the dielectric. Once we insert a dielectric inside the capacitors or separating the two parallel plates of the capacitor, we should know by instant that the capacity will be increased. But then it's quite important. We will come through all these things in mathematical way, and also with experiment, and also with simulation to prove all these things. But important thing is to answer all these literature questions. So we mentioned that we have two types of dielectrics. One of them is a polar dielectrics, and the other one is nonpolar dielectrics. And you will ask yourself, what is the polar dielectric and what is the nonpolar dielectrics? Let's see this. Polar dielectrics are electrically insulating materials, as their particles have permanent dipolar moment. So the spacing between the centers of the positive and negative charge is constant, and such as particles are called dipolar particles, and we have a very good example is the water. Let's understand what is this. So when we talk about a polar dielectric, we talk about a dielectric between two parallel sides, plates of the capacitor. They are connected. These, we have that positive and negative charges, okay? In this polar isolating. The distance, sorry, let's change the color here. So the distance between these charges, the center of these charges, is constant. And that means this material, or this isolating material, the dielectric itself, is a dipolar. But in another way, the nonpolar dielectrics, they are electrically insulating materials, such as the first one, and the spacing between the centers of their positive and negative charge is not constant. So we cannot identify the distance between their positive and negative. It's not constant. Sometimes it's here, sometimes one is here, one is here. So it's quite different from the polar dielectrics, because the distance between the center of the positive and negative charge are not constant. And both of them, they will be affected when they entered inside a dielectric, when they entered inside an electric field. So we see here that the nonpolar dielectrics, their distance between the charges are not constant, and when they entered into an electric field, these particles, reactants, have temporary dipolar moments, such as a glass and polyethylene. And let's imagine that. And so let's imagine here that we have a capacitor of two plates, okay? And then we have entered a dielectric of nonpolar dielectrics. Okay, and one of the charges is here, 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 for instance, for example only. And then we know that when we provide it with a power source, that this side will be negative and this side will be positive. And once and for all, that whenever there is a side of a positive charge and a side of negative charges, that there will be an electric field starts from the positive charge towards the negative charge. That's how it is. And then, what is happening? Why we are bringing this example? Because this dielectric, the nonpolar dielectric, will be affected and dominated by this electric field. What will happen? All these charges will be affected and will be re-establish their location by this. So now we will have the negative charges will become near to this side, and the positive charges will become near to this side. In the same way of the electric field. This is what happened. So if we want the difference between the polar and nonpolar dielectrics, let's take a quick look on this one. So we say that the polar dielectrics and the nonpolar dielectrics, so the polar dielectrics, when placed in electric field, its reactants have a permanent dipolar moments, that the dipolar moments will become permanent. But in nonpolar dielectrics, when placed in electric field, as we have mentioned, reactants have temporary dipolar moments. So when this source of power released, then we will see that we have that this momentum, dipolar momentum, will be released again because this is nonpolar material. While if it's a water or a polar materials, it will remain as it is. This is the first difference. The second one that we know, the polar dielectrics, the distance between the centers and its positive and negative charges is constant, as we have mentioned. But in nonpolar, the distance between the centers of its positive and negative charge is not constant. And the third and the last one, the examples. So this is one such as the pure water for the polar, and nonpolar such as the glass and polyethylene. For now, this is our lecture. Talk about what is the capacitor and what is the capacitance depend on. We mentioned 3 elements. And then we talk about also the dielectrics and the type of dielectrics. I hope this is quite easy for you. Please stay tuned for other lectures.